Hello again, this is Mark Summers from Summers Technical Services. We're going to run through a stress analysis problem that we did in Chapter 3 and see if we can't get the same answers on our hand calculations that we've got, or same answers on our Solidworks simulation as we got on our hand calculations. We should be able to duplicate those values. So I've built the model for you, I put it on canvas for you. You need to go into each one of these parts and open them up and change the diameter of the brass part and change the diameter of the steel part to the values that you calculated for the problem from the textbook. Save those parts and then open up the assembly. The assembly will update with those new values. So once you do that, I've done that on mine already, I'm going to go to the simulation tab and I'm going to say new study, and I'm going to call this TSU-100-00- A03 FEA. Finite element analysis. So that's good. So I'll say OK. Now I'll just answer questions left to right here. So I've already done the new study. I want to apply the material. These are two different materials. So I've got to select one of them, hit apply material. And since I've already assigned brass for the material, in the part model, it's going to pull that data over into the simulation tab. So I'm going to say apply close. I'm going to select the steel part, apply material. This is the steel part I assigned AISI 1020 steel. I'll again hit apply close to assign those material properties. Alright, now the next button is fixtures. I'm going to use the pull down and say fix geometry because I want to fix the bottom so there's no translation. And so that locks down the 3 degrees of freedom in X, Y, and Z translation. Fixed geometry, I'll say OK. Now it's time to add the torque. So I want to come to external loads. I want to use the pull down, go to torque, and I want to do what it says. The blue box here says give me the face where the torque is applied, which is right there. I want to activate this blue box, which defines the axis that the torque acts about, and that'll be defined by the axis of either one of these parts here. Either one's fine. The axis going through that cylinder is going to be defined as what the torque is applied about, and that's what I want. And you can see the display, the arrows are going in the right direction as assigned on the problem in the textbook. And I need to add a value. I've got 10. My problem has got 10 kip inches, which is 10,000 inch-pounds. So first change the units. Always check the units it's asking for. I want English units. And for inch-pounds, I don't want 10. I want 10,000. And you'll put your number in that you were assigned. I'll say OK. And now the problem's ready to run. So I want to make a mesh. I want to use the pull down. Under run this study, I want to create mesh. I got a speedy computer, so I'm going to slide that over to find mesh and say OK. And it meshes it really quickly. It's got a pretty good mesh there. I think this will be good enough for me. So now I want to run the study. So I want to go ahead and save this before I run. You should do the same thing in case it crashes. I'm going to say run this study. And it's plugging along. I got 250,000 degrees of freedom. And it solves it pretty quickly. I'm going to turn off the form result. Now it's got all the answers I need. I just need to ask for what I want. And what I want is the shear stress on the Y face. See the axis going vertically is the Y axis. So the face that's perpendicular to the Y axis is the Y face. So I'm going to ask for either tau YX or tau YZ. One of them is this shear stress on the Y face in the X direction. The other one would be the shear stress on the Y face in the Z direction. So I'm going to right click on results, define stress plot, and choose one of those two options. I'm going to use the pull down to choose tau YZ. That was one of those two options. We'll talk in a minute about what the difference is between the shear stress on the Y face in the Z direction and the shear stress on the Y face in the X direction. Either one of those would work. Got to always check the units. I want this thing in KSI. That's the numbers that the book gave us. for our allowable stress, and then I'll say OK. And so now I've got it bold down here. That means it's active. I'm going to turn off that deformed result. And now I'm going to ask for the shear stress on the brass part, and then I'm going to ask for the shear stress on the steel part. And I'm going to probe it to find the shear stress at the perimeter, which is where C is maximum. TC over J calculation we did on the hand calculations. When C is maximum, the shear stress is maximum. So I'm going to go ask for a cut plane through the middle of this brass part. So I'm going to select the top plane, go to Plot Tools, and say Section Clipping. And I want to drag this up somewhere here in the middle of this BC part, the brass part. And I'll say OK. Now I'm going to look down from the top and I want to probe that face to find out what the shear stress is. And so if I probe here and here, well, I want to probe all four of them, then we'll talk about it. You go to Plot Tools and say Probe, and you want to probe it right at the perimeter, right at the very perimeter, on these quadrant points. So I got those two, and then it looks like in the middle, get as close as you can to the edge, right in the middle. So let's look at these values. So you'll notice on the top and the bottom, the value is near 0. It's 5e to the minus 3. That's near 0. This one is 2e to the minus 2. These are both 0 because this is asking for the shear stress on the Y face in the Z direction. But at the top and the bottom, the shear is going left to right, which is the X direction. So that's why there's no shear stress top and bottom. On the left and right side here, though, there is shear stress. This one is 7.9 KSI. That's the shear stress in the Z direction. That's going up and down. That's the direction the shear stress is acting. And then over here on the right is positive 7.9, which is very close to 8. That was my allowable stress on the hand calculations that I was the input to the problem that I was given. And so I think this is a good analysis. So what you're going to want to do is take a screenshot that shows these probe points, shows the legend with the axis, with the legend with the header on it that tells me you're asking for the shear stress. Make a screenshot of that. So let's go grab a screenshot. That's not it. Where's my screenshot guy? Right here. We're going to say new, and you're going to make a screenshot that captures all that data, and you're going to save that on your computer in your AO3 FEA folder, and you're going to call it TSU-100 your student ID -03-FEA, and then give it an underscore brass so I'll know that's the one for the brass. We'll do another one here in a minute for the steel. So save that screenshot. Now we'll get out of here. Say OK on the probe result. I'm going to do a space bar, get an ISO view. I'm going to go back to my Plot Tools section clipping, and I want to drag this thing up because I want to take a section through the steel piece and maybe right in here somewhere. And I'll say OK. Now I'm going to probe this face and find the shear stress on the Y face. So I'm going to space bar ISO view. And I'm going to go back to Plot Tools Probe, and we'll do the same thing. I'm going to probe at the very top of the steel part. There. Get as close to the edge as you can. If you miss it, and go in here and get another one. That one looks better. So let's see what we got here. So again, at the top and the bottom, this is near 0, which is what I expect because I'm asking for the shear stress on the Y face in the Z direction, and that is going up and down here. The one over here is 1.47 negative because the shear stress is going down because that's the direction the torque is going. Over here, what is it? Well, it looks like it is 1.48 positive. Well, my allowable shear stress, excuse me, not 1.4, 15, 14.7 and 14.7, that's pretty close to 15. That was my input values for allowable stress on the steel part, so I feel very confident then my hand calculations, and this simulation is giving me the same number, which is the correct number. So again, you'll come in here and do a screenshot and capture this data. Where is my... Here we go. Make a new screenshot. Boom. Save. Save this as steel. All right. And now I'm done. So what you'll do is you'll send me an email. Don't send me an email with attachments or with links to files on the cloud somewhere. If you do that, I'm just going to delete them like I've done in the past. Send me 3 attachments. Excuse me, 5 attachments. So let's turn off this ISO clipping or section clipping. I'll go back to section clipping. I want to turn it off by clicking that button right there. Say OK. Now I'm going to save this thing. So you're going to send me 5 files in an email before the start of class on Tuesday. One of them is going to be this assembly model that you've updated with your size tubes. Send me the assembly model, send me the part model of your steel part, send me the part model of your brass part, and send me those 2 screenshots. That's 5 files total. Send that to me before the start of class when this thing is due, and I'll grade that for your grade. We'll also work another problem in class, and if you want to work that one, you can get a little bonus points for assignment 03 FEA. So that's all I got now. Work on that this weekend, and we'll talk to you in class next week.